Okay, and we're recording. So let me share in the chat the agenda we have for today. So as usual, first of all, I'd like to request approval for the meeting minutes from our last meeting for the month of May. This will be done on GitHub. If everybody's okay with that, then we'll merge them shortly. Okay. So as announced, so today we have a guest who's going to present to us pretty interesting project that we talked about in past meetings, the ROS project, a framework for quality assurance of ROS-based code, mostly based on static analysis. I think I shared a short presentation that Andre here had made before, just for background, and we're very excited to have him today. So as you know, Andre, this working group focuses on developing tools and improving the developer experience for adding security in ROS2 based projects. So security in ROS2 in general, and the people here today have contributed to major projects like SROS2 packages. So that is really exciting to hear about your project. There could be a lot of opportunities for synchrony, so working on this topic as well. So yeah, I'll give the floor to you. Feel free to introduce yourself and anything you have prepared, and then we'll just have a short discussion, just open to questions and exchange of ideas.
All right, sounds good. So again, my name is Andres Santos. I believe maybe okay. I know that a few people, at least in this working group, I have already met in the past, but not sure if they are present today. Anyway, my expertise is not so much in security; it's more on safety. But be that as it may, the two areas are actually very related to one another, and they are usually both desirable traits, especially in critical systems and high assurance systems. And my background has been mostly researching this topic since my master's thesis, which was when my my work began on this ROS framework. It's been my main occupation all the way since that master's thesis, all the way through my PhD, and now even in my contract work. So the basic idea is that we are trying to find ways and to develop tools that automatically or semi-automatically detect issues, bugs, and try to improve the overall safety and correctness of ROS applications. And I think that with that, I may move on to the presentation. Let me just grab the screen. And I believe that my screen shall be sharing right now.
Yeah, you can see.
Yeah, so basically the introduction is all done, and yeah, like I was saying, I believe that both people in safety and people in security know that developing robotics software is quite a challenging problem, because not only there are many complex isolated problems to solve in robotics, but integrating all these different areas into a single system with a single goal in mind is quite challenging as well, and brings forth new problems on its own. Software engineering is the domain or the skill that helps us verify desirable software properties using various techniques such as testing, runtime verification, model checking, etc. But the main problem that is often pointed at these techniques or raised as a concern is that these techniques often require expert knowledge that most of the people won't have, right? Most of the developers won't know what is a model checker, for example, and they are not going to spend their time learning how to use them if they could be developing systems instead. So the question then is, how can these existing techniques that are powerful and proven to be useful be adapted and used by non-experts in order to improve the quality of ROS applications? This has been the core question, basically, of my PhD thesis. And the ROS framework was developed and proposed as a possible approach to this problem. So the main ways in which this is better, so to speak, than using the known techniques directly, is that normally these techniques are already a high barrier to entry from the start, right? They require already complex inputs from the user, like formal models and such. And this framework instead takes source code directly as its input. So it works directly with the source code, which is the language that the average user is used to use in everyday activities. And then we do some reverse engineering, some model extraction in order to rebuild the formal models that we actually need from this code, and then specify the properties that we want to verify using a high-level property language that is more or less like a script, something very almost English-like that people can easily read instead of writing Greek symbols and logic formula and such. So to put this in perspective, we basically start with the user providing an input file that we call the project file. This file basically specifies the systems that you want to analyze and the properties that you want to check on these systems. This is fed to the tool, which then fetches the corresponding source code and feeds it to a series of analysis plugins, each providing a different analysis capability. In the end, it outputs a variety of things, such as data files, runtime monitors, for example, if code generation is part of your plugins, runtime models that it used as part of its extraction process, and issue reports, etc. So as a small example of this input, you have here on the left in YAML syntax, basically three things. That's the name of the project that you are analyzing. It's basically so you can separate the results in different databases, a list of packages that you want to analyze, and then the systems themselves here expressed in terms of the launch files. Then, given this type of input, the tool will start working on its own based on your environment, of the system, etc., trying to locate the code and then proceeding into model extraction. And visually, this is more or less what you get in terms of model extraction. We have on the left a feature model, which basically extracts the high-level features that are available. So here the feature is more or less an abstract and maybe debatable term. because it's not really defined in the ROS documentation what constitutes a feature. But for our purposes, we basically consider features the launch files, which are more or less top level, and then things like arguments, nodes, and things that influence how the computation graph is going to look in the end. So things that alter the shape of this graph. And on the right, the actual computation graph that results from the selected features on the left side. This includes basically all possibilities. Like for example, we have here these dashed circles that represent conditional entities that may or may not be present in the final computation graph, depending, for example, on an if condition. That the tool also allows you to inspect. Right at this level, before any other kind of property is verified, you can already start checking if everything is all right. For example, with architectural queries, you are allowed to write down some simple queries in a more or less a Python-like query language that then highlights matches in the computation graph. For example, here we can see a simple query showing that asks the visualizer to show topics for which there is more than one publisher. And these, if they have a match, they turn red. So in this example, we have these 3 white circles, the nodes that are publishers on that topic. Moving on to more interesting types of properties, we normally want to verify behavior. But to verify behavior, we always hit the Oracle problem, right? We have to be able to specify first what should be correct behavior, so that we can then find a way to check if the behavior matches the specification. And in this case, since ROS is heterogeneous in terms of languages, right? You can have nodes in C++, in Python, Rust, etc. It's hard to come up with a specification that's done in terms of internal state of the nodes, or in terms of language-specific constructs that will not be easy to extend and to use in general. So instead, we treat components and nodes more or less as black boxes on top of a common middleware, which is ROS, and then specify the behavior in terms of messages. So traces of messages are basically the observable behavior. And the idea is to use a high-level specification language, as I said, that is backed by formal semantics, but the semantics are actually hidden away from the user. So basically, a property has 2 components, a scope and a pattern. The scope defines when a property should be valid. So you can have properties that are always active, so to speak, or properties that are only valid up until a certain point, or after a certain point. For example, suppose that you have initialization or setup phase, and only after a specific trigger you want to start verifying normal behavior. That is what these scopes are for. And the patterns then are a sort of definition or description of what should be happening within this scope. So you can specify absence of undesirable messages, or the presence of desirable messages, messages that lead to other messages, or messages that require previous messages, and such. And these patterns can be timed or untimed, so that they can also have limits in terms of real-time especially for these binary patterns. It's especially important to ensure that you have responses within a specific threshold and so on. So, for example, let's say that we want to specify that when the laser detects an obstacle closer than 40 centimeters, a zero velocity message is published in response within the following 500 milliseconds. This is how it will look in this language. This property is global, is always active, and then a message on the laser with a distance field less than 40 causes a response in the velocity topic with the linear x field set to 0 within the 500 milliseconds afterwards. So we can do a number of things with these properties. We have some plugins, for example, experimental plugins for model checking, mostly developed by master students. We have also developed by me and the two plugins, one for runtime verification and another for property-based testing. And property-based testing, if you don't know the term or if you aren't familiar with it, is basically an automatic testing technique that works with general purpose properties, more or less like we have in this case, things that should always be true or true within a specific context, and then automatically generates more or less randomly a large number of inputs and repeatedly tries to test the system or the function or whatever you are testing with these generated inputs, trying to break the property first, and then trying to find the smallest reasonable counterexample to display back to the user. So this is more or less the workflow of this property-based test plugin. We start with a specification or the properties that I just showed. We take also the computation graph, which is automatically extracted from the source code, and the message definitions for each type of message, which should be available in the ROS installation on the system. The plugin puts all this together, produces a test script that then automatically generates traces of messages, enables runtime monitors, and runs a testing loop trying to find counterexamples for the given properties. In the end, it shows reports for the properties then that fail, something along these lines. It shows which property failed and a counterexample. In this case, the counterexample contains only one message with a distance of 0 on the topic laser at that given timestamp of the execution. So this is more or less what the tool is capable of. The main goal of this project, this framework, is to bridge the gap between robotics and software engineering, or developers and experts in formal methods and software engineering, in code quality, etc., which in a way also includes security and should include security as well. It offers a variety of different analyses, always with the goal of requiring as little user input as possible or as feasible. And the system and property specification is iterative and partial. You can start with very small systems, very small specifications, and add more to it as you go. In terms of current status, this has already been tested with a number of academic and industrial case studies, and development for the current version, which only works with ROS 1, is suspended because I'm currently basically rebuilding the tool from scratch to work with ROS 2 and to improve a number of things, mostly internal systems, trying to make it more easily extensible, adding more more hooks for plugins at different points, and maybe not only for analysis and such. So the current goals is basically are basically to rebuild, finish rebuilding this tool, enable ROS to support from the start, maybe take this opportunity to integrate with new conventions such as the NoDL language to specify systems. It's probably now a good time to study this more in depth and try to integrate it as well, since we also have to describe systems in a way, and possibly going beyond safety, including, for example, security analysis plugins and so on. And yeah, I think that basically wraps up my presentation. I would rather discuss and hear your questions if you have anything in particular. So thank you for your time so far.
Okay, thank you so much, Andre. Thank you for this presentation. So feel free to open your mic anytime and ask any questions you have. Yeah, that was really great. And I'm really happy to hear actually that you're working on ROS2 support, and also that you're aware of NoDL and you're planning to integrate and take advantage of that as well. That is one project that people from this working group have contributed to. So that's pretty cool. And that was actually one of my questions, like how do you see that tool, for example, projects like NoDL interacting well with HROS and benefiting from it?
Yeah, I've heard of the NoDL project a few months ago, maybe late last year or something, and it was an interesting initiative for me right from the start, because I already had to develop for ROS one a meta model that describes what essentially is a ROS system, right? Including the whole computation graph, the source code entities that end up building this graph and such. And when I saw this, I thought, well, that's certainly better to have a language defined by the community and that is known within the community than having me define sort of ad hoc, not ad hoc, but specific formats to this framework that maybe people will not be using in other contexts. So definitely, if I can piggyback on something that is more or less standard, that will be ideal, and I will certainly try to integrate this language within the current design of the new version for this tool.
Yeah, I will say, the first thing that I was going to ask about was going to be the ROS versus ROS2 thing. I was over here, kind of searching through the GitHub repository just to confirm my suspicions on that. So yeah, I'm also really glad to hear that that's moving forward. I'm curious about, the way that you've got the, properties set up to define, what the expected behaviors are, and then going through and, trying to generate counter examples. How large of a concept can that really, contain? Because, the example here is pretty straightforward of, okay, if I see this thing at less than 40, then I should therefore expect this other one to appear with a 0. But I'm kind of thinking of some of the larger scale real world examples. There may be some cases where you have something that's at that level of complexity, but frankly, a lot of other ones are going to be more involved, and there will be multiple different inputs coming in to describe a particular expected output condition.
Yeah, absolutely. So I usually use this property as an example because it's more or less intuitive. It's worked well so far, but the language, despite being based on scopes and patterns and more or less limiting in a way, it also has quite a number of features that enable describing more complex cases. For example, you have disjunctions for topics. For example, here the input is laser, but you could say laser or bumper or whatever wheel sensor or something along those lines. You can have a number of different messages being the alternative inputs, and then leading to also possibly different responses. And within the filters for the messages, so to speak, in this case, the conditions are pretty simple. It's basically distance less than 40, and in the other case, it's linear x equal to 0. But these internal patterns for the messages are also quite complex. They can include every data type that is that is allowed in ROS messages, and you can even have sort of quantifiers and loops over the fields if you want to traverse arrays or describe that. For example, all fields in an array must be less than some threshold. That's perfectly possible. You can have, to some extent, arithmetic operations and such. But the more complex these patterns become, obviously, the harder it is to test and to generate valid inputs as well.
Yeah, that's kind of one thing I was wondering, is it maybe a case where there are a particular, category of tests that are well suited to this, but perhaps others that this maybe isn't the best tool for the job?
Yeah, a particular example that I have is and that I had to deal with in the past was, for example, anything that is related to maps or images, right? Generating random maps or images as inputs is not particularly easy. So we have to adjust the resulting test scripts basically to, for example, select from a data bank or something along those lines instead of just going random. Because most of the time, if you are generating images randomly, it's going to just be noise and won't make any sense. So you're just wasting time.
Am I going to go just pull random images off some of the fun subreddits?
Yeah.
Cool. Thank you.
Could you it escaped me a little bit, but could you go back to the section where you discussed the transitive flow from one subscription and one publication to the other in terms of like these time windows? I didn't quite catch. Maybe you go back in the slides. I think you had it somewhere.
Is this what
Yeah, it's specification of properties and causal and requirements. So here you're discussing about the required outputs and the required inputs, and checking, like if you had a depth camera that was publishing point clouds, RGB images, and maybe a depth map or something, and you have a filter that needs to subscribe to all those three to generate a colorized point cloud. Is that what this kind of scenario would encapsulate?
Yeah, and that case might be a little bit harder to specify, because in principle you might want to have the three inputs be synchronized in some way, right? Or at least delimited by some time window to make sense. And that's one of the things that I wanted to include in this specification, but didn't end up having the time to go all the way through, which was to include what basically in the ROS1 environment is the what are they called, the message filters, I think, that allow you to synchronize the inputs and define policies and such. I think that will be necessary at some point to include in more, to make this language more inclusive, or to capture those types of scenarios. But
Yeah, synchronized messages are a fairly common paradigm in the ROS ecosystem, I guess. So yeah, having a way of describing a message input's deadline with respect to another message's arrival could be useful in that case. Yeah.
Yeah, I can specify deadlines from input to response, for example, but defining that a response is dependent on multiple synchronized inputs is not well supported right now. But I think it's not impossible. It's just a matter of manpower for implementation and including it somehow in the language, so in some way that's not confusing.
Are you using any kind of satisfaction constraint solver in formulating these rules and in this evaluating their truthness, or are you sort of having a sort of a custom framework?
So that's one of the things that we have considered, and that's something that is probably going to be necessary at some point, especially for messages that have a lot of quantifiers or arithmetic expressions. Those are a bit harder to generate automatically. But in many cases, I can evaluate the expressions statically and basically generate code that always produces valid messages by construction. And for some edge cases or other patterns, we may have to generate a few inputs and basically have runtime monitors in place, discarding the invalid inputs until a valid one is generated to proceed with the test.
Oh wow. That's all I had.
Yeah. So basically, like this simple example, for example, here we will have to generate as input traces of messages that include at least one laser message, because otherwise you will never be testing this input and response pattern, right? If you never have inputs, you will never get responses, so the test doesn't make sense. So that's one of the constraints. The input trace has to contain at least one laser message, and in this case, since the pattern itself is very simple, it's just a numeric field less than the static value, then I can basically take that and generate code that always produces valid inputs. So I basically take this condition and make it so the random generators always generate values that are less than 40. Then the remaining messages in the input trace obviously are allowed to be anything, and including other topics that are subscribed by the system, so that we can try to mess with the system and exercise different execution paths.
Just a question. So all these analyses are done live, right? It's not like you're exploiting any, I don't know, offline computation to do that. Also, when you were recreating the computational graph, you're doing everything on the machine, how does it work?
Everything up to this point, up to the extraction of the graph, is just looking at source code. Nothing on the ROS system has to run for, up to this point. Then for the remaining of the analysis, it depends on the plugins. But obviously, the test generator will have to execute the system at some point to run the tests. But other things like model checking, for example, only works with models, doesn't have to run anything, as well as possibly other simple static analysis tools, things like linters and things like CPP check and such that detect uninitialized variables in code and that kind of thing. You can do that only looking at the code. You don't have to run anything. But for tests, obviously, we'll have to execute the system at some point.
But also, here, for example, you have the specification part on the top left corner. That's something that needs to be created by the developer, or it's extracted directly from the source code?
Yeah, the specification is, in this case, is basically the properties. Those have to come from the user. It's in this input file, basically. You have here at the bottom a section in which you will write down the properties or some link to an input file that provides these properties. And but yeah, obviously the properties are always to come from the user, because it's the user. The user is ultimately the person who knows what should be valid in their system.
But in this way, you're also able to detect, for example, if someone has misconfigured or is misusing message types somewhere in the system.
Yes,
Specification. Okay, so you are defining a high-level model of the system, and then you're trying to push it on the real examples with your plugin, right?
Yeah, that's one of the things that we do with this type of queries. For example, we have some that run automatically, that the user won't have to write them, and one of them is trying to detect topics for which there are, for example, publishers and subscribers using different types of messages, maybe because they have a badly configured remapping or something that ends up matching topics that should not be matching, and that can be automatically detected only by looking at the source code.
And did you have the chance to run some robustness examples for the computational graph creation? Since the question came from one of the work that we did with Ruffin on discovering the graph of the robotics system. If this is not the simple publish subscriber, the number of nodes increases exponentially. So what happened is that the graph becomes huge, and it's also complex to run query on it. Do you have the chance to test this, or your examples have always been on the toy examples? Because you were mentioning that you run it on 3 real world robots. So if I'm not wrong, on the Turtlebot, yeah, exactly. And how many nodes you had here? You had any problem with computing the size of the computational graph? Any hiccup or somewhere, or?
No, not really. In these cases, the graphs were not so large that we noticed an impact. I mean, if I'm not mistaken, I think that Turtlebot would have something like 20 to 30 nodes, and then each of those obviously will have a bunch of topics and parameters and services and so on. But yeah, nodes themselves, I think it will be like between 20 and 30. So that's not big enough to slow down the analysis.
All right. And one last question, probably. What about the functional and non-functional requirements? So you have properties that you can express for the robots. For software development, for the DevOps, especially when you want to prove some functional and non-functional requirements for safety. For example, you mentioned that's one of the fields you've been exploring and working on. Do you had some experience in developing those kind of solution as well? Or you only been define properties that are functional, in this case, like the velocity and the radar?
Yeah, so my research topic was mostly related to functional safety, so basically correctness of the system. So that's what I've been mostly working on. But we also have some non-functional requirements captured as well, at least in terms of real-time execution and meeting deadlines. But of course, then there's a lot more to non-functional requirements than deadlines. But yeah, my main focus for research has been on functional safety. So that's what I most easily support up until this point. But my current employer, for example, has a serious focus on security. So this focus might change in the near future.
All right, thanks. And really the last one question. With some of the folks here, we have been working on DevSecOps for robotic systems, and we're waiting for the review, but for the ROS. But we had the chance to discuss about it here in the working group chats and also on Discord. I would like to know if you had the chance to check that out, and if it might be on of interest for you, since you are also targeting now ROS 2 and security as well.
Sorry, I didn't get the question. Can you repeat, please?
If you have seen the work we try to push about DevSecOps, I think it's quite interesting for your research as well. We are trying to reach the same conclusion. So now that we are also pushing for the ROS 2, I was just wondering if you have seen that, and if you have some ideas or some comments about it.
Yeah, I'm not very familiar yet, because I just, despite knowing about the existence of ROS 2 for basically its launch in 2017, I think. I've only recently started studying it, learning it, and I'm just basically I only started in the first months of this year, delving into what's going on in the ROS 2 environment, what's going on in terms of software quality, security, and such. So I'm not yet familiar with a lot of stuff. I basically stumbled upon NoDL by chance, and that's one of the things that I am more or less already acquainted with. But other than that, I'm still in the learning process.
Got it. Thanks.
Yeah, I just shared in the chat link to your research paper. I believe that's the work that you were referring to, Gianluca.
Thank you, Florencia.
Yeah, I see it. Thanks for the link.
And Andre, if I may ask, how many guys you're working in the lab? You mentioned that you're working in the lab at the university, right? How many of you are working on this project? You were mentioning the lack of manpower.
Yeah. So my PhD ended basically July of the last year, and since then I've been working at this Vortex laboratory that you see the logo at the bottom. But the situation is more or less the same. We do not have a lot of manpower yet, and basically the ROS framework has been my solo project since the beginning. So it's basically a one-man job with supervisors.
Wow. Well, and we all have problem of manpower, so
yeah,
that's a common problem.
yeah.
Any other questions?
Kalle unmuted himself. I don't know if you're speaking.
Yeah, just waiting. Actually, I have one fully off topic, which I actually can take offline also in a metric chat regarding one question about DDS or fast DDS pull request that eProsima was wondering. That hasn't been closed. It's been open for like since October or something. I just had a call with them today, and they asked me about it once I said that I'm joining this meeting, and asked me to kind of ask if there is anybody on this call that could help this thing forward. But as said, we are getting full hour, and this is probably something I can take into metrics. I can send it also there in a chat, so you can have a look. But it's basically this BKSS11 implementation eProsima did for fast DDS last year. We worked together on that, and we are now working on something else for fast DDS with them, and this came up. So I promised to pretty much ask around if anybody here knows how to kind of poke this forward.
This seems like it's on the RMW repo, so the client library working group might be the go-to folks with the permissions, at least to merge.
All right. Do they have their own matrix chat, or what's the easiest way to kind of reach them out?
So under the ROS2 working groups on the ROS2.org index or whatever, I think there's an entry for the calendar schedule for the client library. I'm not sure if they have a instantaneous chat, but they do regularly meet. I think like twice every month.
Okay, cool. I'll try to reach them out. Thanks.
Okay, great. I don't know if there are any other comments or questions. Getting closer to the end of the meeting. Okay, great. So thank you so much, Andre, for a great presentation, for your time. It's been amazing here about ROS, very interesting projects and great discussion as well. So you're very welcome to join us anytime. So we're holding this meeting once a month. It's a community meeting, and it's always announced on ROS Discourse. Hopefully there'll be no time confusion next time, so make sure of that. But yeah, it'd be great to have you in the future and continue these discussions.
Sure. Thank you so much for the invitation and for having me here. We'll definitely keep a closer eye on the future of these meetings and this working group. Thank you.
Okay, sounds good. We'll see you all next time then.
Bye-bye, folks.
Thank you very much. Thank you, Andre.
Bye.
Bye,
See you.
guys.
Thank you.
Bye-bye.
Thanks. Cheers.